This videotape will show you some of the tools and instruments used in laying out work for machine operations. You will also be shown the procedure to follow when doing semi-precision and precision layout of a workpiece. The quality of workmanship in machining depends a great deal upon the care and accuracy exercised in laying out the work. After viewing this tape, you will be able to write down the safety precautions you should take when working in the machine shop, write down the names and uses of layout tools, and write down the procedures you should follow when making semi-precision and precision layouts. You must remember that accidents don't just happen. People cause accidents. To protect yourself as well as others around you, take these safety precautions. Always wear your safety glasses. Keep your sleeves rolled up above the elbows. Remove jewelry such as rings and watches. Keep the area around you neat and clean. And many of the layout tools have sharp points, so handle them with care. Layout is a process of making reference marks on a workpiece before you start machining. The dimensions and placement of these marks are taken from a blueprint. Blueprints give a picture of the unfinished part, but these pictures have to be interpreted by the machinist. Many blueprints are drawn to either a larger scale or to a smaller scale than the actual machine part. It is made larger to clearly show the machinist all the dimensions of a small workpiece, or made smaller so that all views can be shown on one sheet. However, when you lay out dimensions on a workpiece, you should always make the layout to full scale or actual size. The layout can be classified as either semi-precision or precision. This determination is based on the precision or accuracy of the layout tools used. Before you can start doing any layout, you need to clean off the layout surface and cover it with a thin, even coat of layout dye. This provides a dark background to allow the layout marks to be clearly seen. Some of the tools used for layout are scribers and dividers, which are sharp, pointed tools for making thin lines on the workpiece. Another tool is the hermaphrodite caliper, which has one bent leg and a sharp point at the end of the other leg. It is used for transferring dimensions and marking lines on the workpiece. Scribers, dividers, and hermaphrodite calipers are all marking tools which must be used with a steel rule in the layout process. The combination set is a multi-purpose layout tool set that comes with a steel rule, a square head, a protractor head, and a center head. The square head can be used with a steel rule to set a dimension and then transfer it to the workpiece where it can be marked off. The protractor head is used for setting lines to the proper angle and then transferring them to the workpiece to be marked off. The center head is generally used on round stock to lay out a diameter or to find the center. The prick punch is a solid steel tool, sharpened at one end to an included angle of 30 degrees. It is used, along with a layout hammer or small machinist hammer, to make small indentations on the workpiece. These indentations are used to mark the intersection of two lines or for placing the leg of a divider when scribing circles or arcs. The center punch is a heavier punch and is generally used after the prick punch when you are laying out marks for drilling. With the center punch, you will need a heavier machinist's hammer. The automatic center punch can be a useful and time-saving tool when you have to make a number of center punch marks on a workpiece. Another layout tool you should be familiar with is the surface gauge. It has a base, an adjusting screw, a rocker, a spindle, and a scriber. You can use the surface gauge with a square head and scale for making lines on the workpiece or for transferring dimensions from one workpiece to another. Now that you have seen how these layout tools are used, let's go through the procedure of doing a semi-precision layout of a cover plate. As you look over the blueprint, you will notice that it is drawn to full scale and that there are two notes. Note 1 tells the machinist that the clearance hole E also has an 82-degree countersink for a flathead machine screw. Note 2 says that you must drill and tap hole F for a 1/4 20 national corkscrew thread. You will also notice from the blueprint that you must start out with a piece of stock 1/4 inch thick and 2 inches wide. The stock should also have one end machined square to the side to provide a reference point. Use a thin, even coat of layout dye to cover the surface of the workpiece. Layout of the workpiece will be performed on a surface plate, which provides a flat, accurate surface for setting dimensions. The first step is to set the surface gauge to the overall length of the workpiece, which is 3 inches as indicated by dimension B on the blueprint. A square head and full scale is used to set this dimension on the surface gauge. With the surface gauge set at 3 inches, hold the workpiece against an angle plate to keep it square and mark off the overall length. Since this is a semi-precision layout, you could have just used the square head and the scale to mark off the overall length. Your next step is to set the square head and scale to 5/8 inch and make a mark for hole E. Now set the square head and scale to 1/2 inch, which is shown on the blueprint as dimension A, and mark a line which will intersect at the center point for hole E. The next step is to lay out the arc labeled D, which has the radius of 1/2 inch. With the square head and scale still set at 1/2 inch, mark a line 1/2 inch from the side of the workpiece and another 1/2 inch from the end of the workpiece. The next step is to locate hole F. Set the square head to 1.5 inches and mark a line from the reference end. Reset the square head to 1.25 inches and lay off the other intersecting line from the reference side. Lay the workpiece on the bench and prick punch the intersecting lines for the radius. You can also prick punch the center of holes E and F at this time. Using a scale, set the dividers to 1/2 inch and scribe the arc at D. Reset the dividers to 1/8 inch and lay out the 1/4 inch diameter hole E. The blueprint shows that hole F is to be tapped for a 1/4 20 machine screw thread. By referring to the machinery's handbook, you see that the tap hole for a 1/4 20 thread is a number 7 or 201 thousandths. Set the dividers to slightly under 1/8 inch, and this will give the proper radius to lay out hole F. Don't be too concerned about estimating the radius of hole F, since its accuracy is determined by the center point. The tap drill will drill a hole of exact size for the tap. The next step is to lay out the notch in the corner. Set the square head and scale and mark a line 1/2 inch in from the side of the workpiece. The blueprint shows that dimension C is 1/4 inch. Since this dimension must be laid out from the reference end, you have to set the square head and scale at 2 3/4 inches. You arrive at this dimension by taking the overall length, 3 inches, and subtracting C, which is 1/4 inch, to end up with 2 3/4 inches. Mark the line with the scriber. The final step is laying out the angle. The blueprint shows that the angle is cut 1/2 inch from the end. Since your measurements must be taken from the reference end, you must set the square head and scale at 2.5 inches, which is the overall length of 3 inches minus the 1/2 inch from the end. Mark off this point for laying out the angle. Now, replace the square head with a protractor head. The blueprint shows that angle H is at 30 degrees from the side of the workpiece. Set the protractor to 30 degrees. Lay it alongside the workpiece and mark off the angle. You have now completed the layout of the workpiece to the exact dimensions indicated on the blueprint, and they both look the same. This layout is called a semi-precision layout, since the smallest dimension on the scale was 1/64 inch. To do precision layout work, you need additional layout tools and instruments. Let's look at some of these precision tools. The vernier height gauge, when used on a surface plate, can lay out work to an accuracy of 1/1000th of an inch. Two other accessories you can use with the vernier height gauge on the surface plate for precision layout are the angle plate and the V-blocks. The dial test indicator is a sensitive instrument you would use to precisely align a workpiece on the angle plate. A sine bar and gauge blocks are used on the surface plate for the precision layout of angles or for checking the specifications of machined parts. We will do a precision layout for the same cover plate that was laid out previously. Start with a workpiece with one end machined square to the side for a reference point, and the layout surface covered with layout die. Since the stock for the workpiece is thin, you use an angle plate for support while making the layout. Place the vernier height gauge on the surface plate and set it to 5/8 of an inch, which is 625 thousandths. Put the workpiece against the angle plate and mark the 5/8 inch dimension for hole E. To lay out dimension A, reset the vernier height gauge to 1/2 inch, which is 500 thousandths, and turn the workpiece on its side. You can now mark off this dimension to locate the center of hole E. You can lay out the center point for arc D by first turning the workpiece on the side and marking off the 1/2 inch dimension with the vernier height gauge. Then turn the workpiece up on the end and mark off the other intersecting line. Hole F is located 1.5 inches from the reference line, so reset the height gauge to 1 inch 500 thousandths and mark off this dimension. Hole F is also 1¼ inches from the reference side, so set the height gauge to 1 inch 250 thousandths and mark the center of hole F. Lay the workpiece on the bench and use a prick punch and small machinist hammer to mark the intersecting lines for holes E and F and radius D. Set the dividers to 1/2 inch and lay off the radius D. Reset the dividers to 1/8 inch and lay off the 1/4 inch diameter hole E. For hole F, you must reset dividers and mark the 200 thousandths diameter. With a center punch and a larger machinist hammer, mark the centers of E and F for drilling. To lay out the notch, set the vernier height gauge at 1/2 inch, which is 500 thousandths, and make a mark from the side. Reset the height gauge to 2 3/4 inches, which is 2 inches 750 thousandths. Turn the workpiece to rest on the reference end and finish marking off the notch. Reset the vernier height gauge to 3 inches and mark the overall length of the workpiece. To accurately locate where angle H starts, set the vernier height gauge to 2½ inches, which is 2 inches 500 thousandths. Mark a line on the workpiece. For a precision 30-degree angle, use a sine bar and gauge block. First calculate the height for the sine bar and set it to 30 degrees against the angle plate. Next, set the cover plate on the sidebar against the angle plate. Readjust the height gauge to the starting point of the angle, which is 1/2 inch in from the end. Now mark this angle. The completed precision layout looks exactly like the drawing on the blueprint and is accurate to the 1,000th of an inch. When you compare the semi-precision and the precision layouts, it is difficult to tell them apart. However, when you machine these parts, you will notice the increased accuracy. Let's review what you've seen on this videotape. You have seen some of the basic layout tools and how they are used. The process of laying out a workpiece working from a blueprint, how layouts can be classified as semi-precision or precision depending on the accuracy of the tools used, and you were given some safety precautions to follow in the machine shop. Your ability to lay out work quickly and to the precision level specified in the blueprints is an important quality, making you a better machinist.